Hello everyone, you're welcome to today's class. In this class, we want to continue our topic and we are still on sequence and series. But today we're going to look at another aspect of sequence and series, and that is geometric progression, as you can see from the board, which we call GP, geometric progression. So under this topic, we'll be looking at these objectives. The first one, we want to define what a GP is, and I want to look at how to calculate the nth term of a GP. Then we look at geometric what mean. So that's what we want to achieve in this class. So the first one is a meaning of geometric progression. Geometric progression is a sequence in which each term of the sequence is obtained by either dividing or multiplying the preceding terms uh, by a constant factor, which that constant factor is what we refer to as common ratio. Don't forget that of AP is a sequence in which each term of the sequence is determined by either adding or subtracting the preceding word terms. So let's say for instance we have 2, we have 4, we have 6, we have 8. So mere looking at this, you notice that the first term, which is 2, to get the second term, if you add 2 to 2, you get 4. If you add 2 to 4, you get 6. If you add 2 to 6, you get what? 8. So which means that this sequence you have here is an AP, not a GP. But if you look at the second scenario, we have 2, we have 4, so we have 8, we have 16, we have what? 32. If you look at this is not this is not an AP, is not arithmetical progression, because if you look at the difference we have between the first and the second term is 2, but between the second and the third term is not 2, is 4. Between the third and the fourth term is 8. You can see that the constant difference between the two are not the same. In that case, this is not, it has no common difference. But rather, if you look at this, okay, if you multiply this by 2, you get 4. Multiply this by 2, you get 8. Multiply this by this, you get what? 16. That means it is multiplying by a constant factor, which refers to as common what? Common ratio. Hope I'm making sense. So common ratio. And is either it is multiplying or it's what? Dividing. So that's what refers to as such a GP. So let me just give a small note on that. It's the simple definition of it. I've explained this. A geometric progression is a sequence in which each term is obtained from the preceding term by multiplying or dividing by a constant factor. And that constant factor is known as common ratio, which is denoted by what? Letter R. So let's look at this and see how we can form the term. We've defined it, then want to find the end term of a GP now. So let's look at this example we have. I'll use that same example that I used the other time. That's 2, 4, 8, 16, 32, and so on and so forth. Let's have it this way. Now, so the first term is A. So term 1, which is referred to as A, is what? Is 2. To get the second term, and the constant factor here, it is being multiplied by 2 times 2. This is also what? Times 2. And this is also what? Times 2. This is also what? Times 2. So you times this one by 2, you get this. Times this one by 2, you get this. Times this one by 2, you get this one. This one by 2, you get this one. Right? So then the second term will then be what? The first term, which is 2, multiplied by the constant factor, which is 2. That gives us what? 4. So that way we can conclude that the first term, which is A, multiplied by what? The constant factor is what? R. So that gives we have what? AR. Then the second term, which is term 2, we can have this. You don't forget in our previous video is that you use T or use N, N1, U1, U1 or U2. So it's the same thing. So term 2 will then be the second, the term 3 rather, sorry for that. Term 3 will then be the second term, which is what? 4 multiplied by constant factor 2 will give us what? 8. So what is our term 2? This is our term 2 here, that is AR. Are with me? Is AR multiplied by the constant factor R. So this will give us AR. R times R will be what? R squared. As you can see. Then the fourth term will then be the fourth term is this. That will be the third term, which is 8 multiplied by a constant factor. So the constant factor R, which is common ratio. That means it's going to get 16. So that means this 8 here is the third term, which is this one, AR cubed, AR squared, AR squared, multiplied by the common ratio, which is what? R. So this will give us what? AR raised power what? AR raised power 3. So if it is nth term, or this nth term, it is still the same thing as the first term here, multiplied by R. So we now look at this. You notice that when you want to get the second term, you only multiply by R. Third term is R raised power 2. So if you pick these three, the third term, that 3 minus 1 will give us what? 2. 4 minus 1 will give us what? 3. 5 minus 1 will give us what? 4. So first term is what? 4 minus 1 gives 3. That means the number of term, which is n, that we don't know now, minus 1. So this will give us the nth term of is what? AR raised by n minus 1. So we can as well refer to this one as what? Last term. As what? Last term. So there's some question that will come in this form that it will be talking about last term. Hope this is very clear. So that is the formula for calculating n term of a GP, that is geometric progression. So the next stage now is to look at examples on this. Then we solve examples before we move to the next one. Look at these 3 examples. So this is what we want to solve. Let's start with the first one. The first one is this. Find the 38th term of this sequence. We don't know whether this sequence is a GP or an AP. So the first thing we need to determine if this sequence is an AP or GP. So let's look at that. We have 10, 20, 40, 80. So the difference between this and this is 10. While between this one is what? 20. And this one is what? 40. So that means that this is not an AP. So it's going to be what? GP. So let's now look at, so what is going to be the multiplying factor? For us to get the common ratio, will be what? The second term divided by the what? First term must be equal to the third term. Let me write this. So the common ratio is T3 divided by what? T2 divided by T1 must equal to what? T3 divided by what? T2 must equal to what? T4 divided by what? T3. Exactly, which must be the same. So in that case, what is our T2? 20 divided by this C1, that is 10. Then this gives 2. If you do the same thing, T3, which is 40, divided by what? 20. So this will also gives what? 2. So which means the common ratio R here, R is equal to what? Is 2. That is, each term is obtained by multiplying the preceding term by 2, by a constant factor, common ratio, which is 2. So 10 times 2 gives 20, 20 times 2 gives 40, 40 times 2 gives what? 80. So let's now look at the 38th term. So we are asked to find the 38th, and that is U38, UN already. UN is what? AR raised by n minus 1. So our A in this question, so it will be U38 will then be what? A in this question is what? 10. And we find our common ratio, where n here will then be what? 38. So we can then conclude that A, which is 10, multiplied by the R, which is R raised by n 38 minus 1. And that is what? 10 multiplied by R raised by what? 30. What is our R in this case? Our R is of 2. R, that's 2 raised by what? 37. So this one will give us, so it's very long. So from here, this calculus is giving us in the standard form. So we have 1.3744, let's say, times 10 raised by 12. So in this case, you have it in this case. So we have raised by 12. We want to convert it to a normal number. So this will be 13744. Then we have 1, 2, 3, 4. So we remove 4 zeros here. Remove 4 zeros. That will remain 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. So this will be the answer. So this is the answer. This is going to give us the 38th term of this sequence. Is that clear? So that is that. Then number 2. So let's look at number 2. How this is clear. Okay. So number 2. Yeah. Question number 2. If the first, second, and the last term of a GP. Now this one has given us that this is a GP. So which means first term is given to be 4. And the second term, U2, which is equal to AR, is given to be what? Minus 20. And the last term, which is UN, I said it that UN is simple as the last term, and is given as minus, which is AR raised by n minus 1, is a minus 12,500. Right. Good. From here now, we've known the value of our A, but we don't know R. We are looking for N because the question asks us to find the number of terms, which is N. So we're going to use this is what we're going to use to solve the problem. Right. Having known the value of A, we can know the value of R because we are given the first term and the second term. And we've known that radius, common ratio is what? The second term, U2 minus what? Minus A, which is A minus 20 divided by what? 4. So this gives what? Minus 5. Which means the common ratio here is minus 5. We can then put it in this value. So that means we have this one, A R raised by n minus 1 equals to minus 12,500. Are you with me? So let's now put the value there. So A, which is 4, into brackets R, our R, which is minus 5, raised by n that we don't know, is minus 1, equals what? Minus 12,500. So we can divide both sides by 4 just to have this one stand alone. So this divided by 4, this divided by what? By 4. So this cancels this. So 3,125. That's minus. So don't forget this one. We still have it minus 5 raised by n. You can leave it this way, n minus 1. Right. So this one too, we can express this one as products of its prime factor. We can express as in index form. Let's see if we can express an index form. Oh, sorry. So we have, let's use 3, 1, 2, 5. 5 can go, 5 here, 6, remainder 1, 5 here, 2, remainder 2, that is 5. 5 can still go, 5 here, 1, 5 here, 2, 5 here, 5. 5 can go, that is 2, right? 5. 5 can go, 5. 5 can go 1. So this means 5 raised by what? 5. So we can have this one as minus 5 raised by n minus 1 equals to this one, minus 5 raised by what? 5. Plus 1, 2, 3, 4, 5. So that means that minus 5 will cancel minus 5. That is indices. Hope you know this. So that is n minus 1 equals to what? 5. Hope I'm making sense. So that means n, we collect like term, n equals to 5 plus 1. Therefore, n equals to what? 6. So the number of terms in this sequence, in this GP is what? Is 6. Oh, that is clear. Find the number of terms in the GP, which is what? 6. I hope this is very clear. Question number 3 now. So we have the fourth and the sixth terms of GP are this. That means the fourth term and the fourth term with what? AR raised by 3 is what? 1 over 10. Right? And the the sixth term, this is a r raised power 5 is what 1 all over 160 respectively, right? So determine the common ratio and the first term. So in this case, this will lead to simultaneous equation, and this leads to a simultaneous equation, right? So we're going to solve for a and r simultaneously. So what we're going to do first is this. So since we have this, what we're going to do, this is equation 1, equation 2. So it's very straightforward. So we can say divide equation 2 by equation 1. So that means this divided by this. That means a r raised power 5 divided by a r raised power 3 equals to 1 over 160 divided by 1 all over 10. So a cancel a, then r 5, because of division indices, it will be minus 3 equals to 1 over 160 times 10 over what? Over 1, right? So this will give us r raised power 2 equals 0 cancel 0. That is 1 all over what? 16. Are you with me? So this one will give us r squared equals, this one we can express it as in index form. So this will be what? 16 raised power minus 1, which is same thing as 16 will be what? 4 raised power minus 2. So 4 raised power 2, right? Then multiply by raised power what? Minus 1. When you open the bracket, you put 4 raised power what? Minus 2. That means we're saying that r squared equals what? 4 raised power what? Minus 2. Right? So minus we cancel out 2, we cancel 2. So we have r equals to what? 4 raised power what? Minus 1. And r equals to what? 1 all over what? 4. That's the value of r. R equals to the common ratio here, the common ratio which is a, common ratio. So we can compute that common ratio is 1 all over 4. That is value of our common ratio, right? That's value of common ratio. So the next is to find the first term. Since the first term we're looking for now, we just say substitute r equals to 1 all over 4 in any of the two equations. In equation, let's say equation 1. If you substitute in equation 2, you're going to get the same answer. In equation 1 means that a r raised to 3 equals to 1 all over what? 10. So we're now going to put the value of our r here, which will give us a r, which is 1 all over 4 raised power 3 equals to 1 all over what? 10. So we can have it this way. So this will give us a multiplied by 1 all over 4 raised power 3 means 4 times 4 times 4. 4 times 4, 16. 16 times 4, 64. Right? Equals to 1 all over 10. So that means a all over what? 64 equals to 1 all over 10. So by the time you cross multiply, you have 10a equals to what? 64. Divide both sides by what? 10 by 10. So that means a equals to what? 64, 6.4. So that means the value of a of the first term is 6.4, which we can express as fraction. So if you leave it as fraction, 2 can go here 5, 2 can go here 32. That's 32 over 5, which means 6 whole number 2 all over what? All over 5. That gives us an answer. So we'll be able to solve for the common ratio and the first term. So that is how to solve this one if you are given two different that leads to simultaneous equations. So the next stage is to look at the geometric mean. All right, the next one is a geometric mean. So if, for example, if three numbers such as x, y, and z are consecutive terms. So then the common ratio uh, is found as the second. We have x, y, z. They are consecutive terms. So the common ratio will be the second term divided by the first term, the third term divided by the second term. That is found as the second term, which is what, y, divided by the first term, which is x, equals the third term, which is z, divided by the second term, which is y. So from here now, let's now perform an operation here. So when you multiply this by this, that means you're going to have y squared equals xz. Are you with me? So which means that y is the square root of xz. What this implies is that you don't forget that x, y, z. So we have three consecutive terms. This is the middle number, and when we're talking about mean, we are trying to look at the average, the middle number. Mean with like geometric average or geometric means. Mean something as average. So average is looking at the middle number. So that's why when we're looking at measure of averages, we look at mean, median, and mode. Measure of averages. And if you look at, there are some questions that you see that mean, median, and mode, they almost have the same value. So we still refer to as the middle number here. So which means the middle number, which is the geometric mean, can be found by the product of the other two terms, the square root of the product of the other two terms. So that is what this implies. So the product of the other two terms. Let's look at how to apply this in some questions. Now let's consider this question. The third, fourth, and the fifth term of a GP are given as this. Find x. So we're looking for x. So you can see there are just three terms. Now, if we want to find x, so we can use common ratio to find the value of x. How? So it's just that the common ratios can be found this way. I will now show you the importance of this derivative. Now, the common ratio will then be x plus 8 divided by what? X plus 3 must be equals to x plus 18 divided by what? X plus what? 8. So when you cross multiply, we have x plus 8 multiplied by what? X plus 8 equals what? X plus 3 multiplied by what? X plus what? 18. So we're looking for x, right? So this is x plus 8 squared. This is squared, right? So that means we're going to have x plus 8 squared equals to this. So this one is the product of this and this. So that means let's open this one. That will be x squared plus 18x plus 3x plus 18 times 3, 24. That is 54. 54, right? So that means we have x plus 8 squared equals to x squared plus 21x plus 54. Now, let's expand this one. This gives us x squared, right, plus 8x, right, plus another 8x plus what? 64 equals to this x squared plus 21x plus 54. So we collect like terms. That will be x squared minus x squared, right? This one is what? 16 plus 16x. Then this one minus 21x. Sorry. Then plus 64 minus what? 54 equals 0. So this gives 0. Then 16x minus 21x will give us what? Minus 5x, right? Plus 64, this is what? 10 equals 0. We can, this one will be minus 5x equals what? Minus 10. Divide both sides by minus 5 by minus 5. So therefore x is equal to what? 2. I hope this is very clear. So we'll look at some questions later on in the channel and see how we can solve them. So that is the end of this video today. We're going to continue to some of a GP, some of terms of a GP, then we'll look at some of sum to infinity of a GP. We'll look at that one as well in the next in our subsequent video. So if you are new to this channel, don't forget to subscribe and make sure you turn on your notification bell. So anytime I release video like this, you'll be able to get instant notification of it. And don't forget to make sure you give us what thumb up and share the videos with your friends and family. So we'll meet in our next class. Bye for now.